Hey everyone, have you ever just, recorded a video and then your software immediately deletes it as soon as you upload it? Yeah, it's great. So let's do this the second time, take two. Alright, uh, so this problem here wants us to find the value of V1. So V1 is going to be this node right here. Okay. And looking at this, we see that we have a bunch of complex values going on here. So we'll just kind of go and write those out. The top and side here, so 5 angle 0 ohms, just the same thing as saying 5 Z of C. So ZC, notice here and there, they already have them in the rectangular form, so they give that to you ahead of time, which is very useful for us. So negative J10, and then Z of L is going to be plus J15. Okay. A couple things, and I'll just go and throw these up here at the corner. So remember that your J is equal to 90 degrees, negative J is equal to negative 90 degrees, J squared is equal to negative 1, and then 1 over J is equal to negative J. All right. So with that in mind, let's continue forward. So if we're doing this problem here, and we're trying to find V1, we'll do a KCL on it, and we'll assume that all of our currents are going to be leaving the V1 node. So if we go and write our equation out, and down here, quick notice, so V of G will be equal to 0, so that's our reference node at the bottom. So everything along this bottom wire is 0. Okay, so let's go do this nodal equation. So writing it out, we'll do, remember we're going to go from start to finish. So V1 minus 20 at angle 0 over 5 ohms plus V1 minus 0 over J15 plus V1 minus 10 at angle 180 over negative J10. Okay. So, and then we'll set that equal to 0. So let's simplify this out. So we'll do V1 over 5 minus 20 over 5. That'll be at angle 0 plus V1 over J15 plus V1 over negative J10 plus 10 over 180 J10. That's equal to 0. And just right here, all we did was the negatives in the numerator and the denominator canceled each other out. Okay, go for a ride there. All right. So then now let's go and combine like terms. So combining these like terms, we get V of 1. I'll get 1/5 plus 1 J15th plus 1 over negative J10. Then I get 4 at angle 0. This just comes from right there. That looks like a 1, doesn't it? There we go. Yeah. And then from over here, we'll get plus 10 at angle 180 over 10. And remember how we said that J was 90? So 90 degrees. Set that equal to 0. All right. So we'll combine that out real quick. J 1/5 plus, I'm sorry, not J 1/5, just 1/5. 1 over J15 plus 1 over negative J10, negative 4. So how we set up here, so we have 4 at angle 0. If we were to break it up and do 4 cosine of 0, that would give us 4. If we did 4 sine of 0, that would give us 0. So we just have 4 plus J0. So we can just write 4 there. So 4 and do plus. Let me pull this up here as well. So 10 over 180, or 10 at angle 180, 10 at angle 90. This would just give us 180 minus 90 degrees. This would give us 1 at angle 90 degrees, which is the same thing as saying J1. So here I will write plus 1J, and that is still equal to 0. Okay, so let's use this information now to simplify our parts of V1. So this will be 1/5. This will be, so 1/15 will give us, already have all this written down. So remember how we said 1 over J from up here. 1 over J is negative J. So negative J. And then we have 0.1, and how we have 1 over negative J. So if I wrote, if I wrote 1 over negative J, that would just equal J. And all that is this equation just rearranged. Okay. So that'll be plus J. And this will be 4 minus J1 on the right hand side. We just move those over. Okay, so then now what we'll do is we'll combine our like terms again. 1/5 actually is going to equal 0.2. So this will be 0.2. Combine our J's right there. It was plus J 0.033. And this is still 4 J1. Okay. Now I'm just going to pull this up here. So to solve for V1, we'll just do 4 minus J1 over 0.2 plus J 0.033. And since we're dividing, let's go and use the polar forms for these. So we'll just do the square root sum of the squares to get the magnitude value, and then tangent inverse y over x to get the theta angle. Okay. So this will be a little bit more practice for you, converting those over. So this will be 4.123 at angle negative 14.04. Then we convert the bottom as well, so 0.202, and that'll be angle 9.369 degrees. Okay. So then now all we need to do is divide the front two numbers, and let's go ahead and subtract these back two numbers. Okay. When we do this, this will give us 20.34 and angle negative 23.41 degrees. All right. And there we go. And it's that easy, really. Just just knowing that you need to do nodal analysis on it. You need to know that you need everything in the impedance form, and then I keep stressing that these relations up here are very important. And just knowing that rectangular is what you want to use when you're adding and subtracting, and then phasor is what you want to use whenever you're multiplying or dividing. So knowing that helps you get through these problems a lot faster. Okay, well, I'll see you in the next video.